Now that we have discussed the various properties, theorems and axioms related to linear pair and vertical pair, vertically opposite angles, let's see some applications of the properties in real life. Applications of linear pair and vertically opposite angles. Applications of linear pair and vertically opposite angles is the topic of the session. So let's see some applications related to the theorems and axioms as learnt in the previous sessions related to linear pair, adjacent pair and vertically opposite angles. Imagine I have a problem which says ABC is a triangle. Say for example, I have a line L which intersects another line L2, and there is a ray passing by out here. Now here I have this to be (40°), and then this is given to be 30°. So here I have a problem which says this angle is 40° and this is 30°, and I need to find this angle, and also I need to find this angle and this angle. So here is a question which relates to linear pair and vertically opposite angle properties. So let's see how we can find each of these angles using the condition of 30° and 40°. So let's see how we can find this. As we can clearly see that this is equal to this, as they are vertically opposite angles. If I take the line L1 and L2 irrespective of the ray, I clearly see that this being 40° must also be equal to this angle, which is 40°. Therefore, this angle must be 40°, because since they are vertically opposite angles, and vertically opposite angles are always equal in the pair of lines intersecting. So this equals this being 40. Now let's come to this angle. Now we know that L2 is a straight line, and therefore in a straight line this angle plus this angle plus this angle, each of the angles must be equal to 180. Sum of each of the angles must be equal to 180. So angle this plus angle this plus angle this must be equal to 180. As we can see, if I take the line L2, which is a straight line, I see that this is the angle made by L1, which is 40°, and this is the angle made by the ray, which is 30, but this is 30°, and the remaining angle is what we need to find. So this being a straight line, the sum of each angle, sum of all three angles must be 180. Therefore, this angle will be 180 minus 30 plus 40, because the whole of 180 minus this gives me the required angle, which on further simplification gives 180 minus 30 plus 40, which is 70, where 70 when subtracted from 180 is 110. Therefore, if I take this as x, this as y, and this is z, my angle y would be equal to this. Angle y equals 110 degrees. Now that I have found each of the angles, now the question comes on how to find z. So let's see how we can find angle z, continued from angle x and angle y. To find angle z, now clearly, as I see, the sum of all the angles taken here must be equal to the circle angle, that is 360, because this angle x plus 30 degrees plus this plus this plus this forms one full circle, in which angle in one full circle is 360 degrees. Therefore, I get the circle property coming into existence here. That is, from the diagram, this, I clearly see that 40 degrees plus 30 degrees plus 110 degrees plus 40 degrees plus z must be equal to 360 degrees is how we get from the circle property. By circle angle, or since this is a circle angle, it must be equal to 360 degrees. When I add this, 40 plus 30 is 70 and 70 plus 40 is 110, which is 220, plus z equals 360 degrees, which on further simplification gives, that implies z is 360 minus 220, that implies my z is 140 out here. So my angle z is equal to 140 degrees. Using the circle angle, I can find each of the angles, angle x, angle y and angle z, with their own respective approach. Given the angles, we can find the adjacent or the vertically opposite angles using the properties as learnt in the previous session. Real life applications of linear paired and vertically opposite angles.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.